Okay, we shall start. The first thing that we have to do to create an alignment is to open the Civil 3D software. For that, you have to open the Civil 3D 2023 metric. So it can be 2018 or 19 or whatever. But please be careful that you are going to open 2023 metric, right? Now, those who are first here, those who came first here, now please make sure that you are going to copy this one, this template to your template set. Okay, so you have to take this copy. You have to get it from the folder, right? Because I have given you a folder and there you are having uom dwt. Okay, you copy it, right click and copy, and then here you can go to file, new, and there I have created a folder RDA. So if you want, you can create another folder, because those who were not present last week only, yeah? Otherwise you already have this. Now say I'll put RDA1. Okay, just to show that I'm doing, then you can paste it here. So you can click it and open. This is an error message because this template was created somewhere around around 10 years back, right? So you can pause it, continue with the current command, right? Then you can save this as giving a name in the same folder. Okay, giving the name alignment, right? Alignment. Now the next thing what you have to do is you have to copy your surface drawing to this drawing. For that, first you have to open the surface drawing. I have saved it somewhere, email. So I'll go to desktop, say training alignment, right? Now I'm going to open file, open. What is surface drawing? Piliandala Morotua 3. I open it. Again this error message is coming, ignore it. Okay. And then I'm going to copy this. Now please remember, when you are going to copy, if you want everything, you have to select from the right hand bottom. These are Autodesk AutoCAD basics, right? Otherwise some items may not be selected. So the best thing what I am doing is I am doing it both way. I select both way and then edit copy, and then you can shift into alignment, and then here again I am advising you, because now I know that most of you have just come out of the universities, and what you have done is everything about buildings, okay, not about roads. Now for a building, of course, you can copy something and then go and paste somewhere else. It doesn't matter, anywhere you can copy and paste. But for a road, of course, you have to go for what, to the original coordinates. Okay, otherwise you cannot set out that on the ground. Okay, so you go to edit, paste to original coordinates. Don't just go and paste, right? Paste to original coordinates, right? So it should be somewhere here. Otherwise, if it is not visible, what you can do is you can just put z, enter, that is zoom, enter. E means extend, enter, so it's there. Okay, so this is your what, this is your surface drawing. Then save the drawing, right? Once you have saved it, what you can do is you can close this surface drawing. don't make so many tabs open. Okay, because it's a big software and it's trying to crash. Okay, so just make open whatever that you are working for the time being, right? That's one thing that you have to understand, right? Then you remember last week we created a surface, so you have to import it here. It's not that difficult. What you can do is file, import land XML, and their surface is there. Select it, open, and import land XML. Press OK. So all these things are there in that book. Okay, so you need not to write down. Okay, so now you can see your surface is being imported. Now last time also I told you, if you have any doubt whether it is the same surface, here you can go to surface properties. You can just select surface and go to surface properties, and then surface style should be. Now don't tell me surface style is not coming, because maybe it is this one selected. Okay, so you have to come to information, right? And then go to surface style and contour points and triangles and borders, and apply and press OK. Okay, now here your surface is there. Now last time also I told you that this is some unnecessary information the survey has given. He has drawn it himself, the available profile, so we can just select it and delete it. Okay, now we don't want to visualize this surface to create our alignment. Therefore what we are going to do is we are going to switch off it. It's there but it's not visible once we switch off it. Okay, so we select it, go to surface properties, and then surface style, say no display. Okay, and you may see that some white lines on these things. See, select this one. What is there in if you go to home here in the layers, it is EG break lines. Okay, so what you can do is comfortably you can switch off these EG break lines. Okay, now please understand, now in this drawing you are having the surface, that means your 3D surface is there, and you are going to create the alignment on it. Okay, so we'll start. Now before creating an alignment, one thing you have to understand is creating alignment is just a technical thing. You don't want an engineer to do that. Okay, why an engineer is necessary? Because creating alignment, of course, if I trained a good draft person, a skilled draft person, he will do that. Okay, but why we give that only to engineers? Because there is some theory behind. Whatever theory, because you have to check what is your design speed. Now depending on that, what is the minimum curve radius that you can apply, and if you are going to go for some compound curves, what are the restrictions? If we are going to go for some reverse curve, what are the restrictions? These things you have to know. That is why we engage engineers for highway design. Otherwise drafting is nothing. Okay, so the first thing we have to understand here is, so we will say we are going for 50 kmph. How do you decide that? A design engineer of course cannot decide that. It has to come through a planning engineer. So the planning engineer has to check, so what are the requirements there, whether it is a national road or a provincial road, right? And what kind of purposes that road is going to serve. These things he has to consider, and then he has to, and one thing that you have to remember is, a design speed is a speed that most drivers are going to obey. Okay, otherwise if they are not going to obey, what will happen? Huh? It will be useless. So if you are now just think that in Anuradhapura Padini road there is some speed limit. What is the speed limit? 70 kmph. but people are going at 140 kmph. So what's the point of having design speed, right? The thing is why that happened, because it was a straight road. Once you have a very polished carpet road, so everybody is trying to go by 140. Whose fault? Our fault? No, it's not our fault. But only thing is, there is a part from the drivers, part from the designers. So one thing as designers, what we could do was we could introduce some curves to reduce the speed. But in a country like ours, if you are going to introduce curves for a straight road, what will happen? People will say, their engineers came and they created it worse. Okay, they made it worse. So they are not practical here. But remember, one thing you have to remember is you have in your mind, you have to have what is the design speed that I am going to design. So for this one, I propose 50, because this is, what is this road? This is from university, Moroto University, from Moroto University to Piriandra Road. Okay, there of course this is some urban area, so maybe we can go for 50 kmph. Okay, not 70. This is that famous bridge. Okay, right. So we will start designing. Now the other thing you have to understand, what we are doing there is we are trying to follow because this is a rehabilitation project. We are going to follow the existing center line as much as possible. Okay, as far as possible, as much as possible and as far as possible, both. Okay, sometimes it's not possible. Now we'll start the alignment, right? For that you have to go to alignments, create alignment by layout. There are many methods. I am describing the best method. There you can say best method. There are other methods as well. One thing you can do is you can create, now there is one thing called create alignment from polyline. What you can do is you can draw lines and then curves and everything and then make it a polyline. Finally, using this option, create alignment from polyline, you can create an alignment there. Okay, that's also possible, but that is not a very good method, because then what are you doing is you are not using the facilities provided by the civil 3D. You are doing it your own. So if there are facilities available, why we are going to do it on our own, right? So we'll go for create alignment by layout. So there comes a window. Here you have to give a name. Usually we give DCL, that design center line. So if you have some any other good name, you can put there. Okay, then this type should be center line. Okay, not offset, not curve return, not trail, not miscellaneous. It should be center line. Right, then the starting station is given. If you want, you can change. So you may be wondering why we have to change it, because just think that you are going to go and start somewhere in Anuradhapura. So Anuradhapura, maybe the existing chain age may not be 0. Maybe it is say some 200 something. In that case, you can of course have your correct starting station. And then site. There are no sites available. You can create a site. Site is kind of a group, okay, where you are going to put the alignments. Now if I create one site, say site 1, I can put my center line alignment and say existing tie edges. These two alignments I can put in no what I can do is I can put the center line and design edges. LHS, RHS, design edges I can put in one side, and the available that means the existing tie edges I can put in another side. Okay, and the other thing is you can have two sides and put it that way, or you can have one side and then put everything together, or you can have no sides at all. That depends on your preference. Okay, so what are you going to do now? Why what is the uh, you know what is the usage of putting them into sites is, if you want to delete a set at once, you can delete them. Okay, so we'll go for now. Usually in my practice I put all these alignments. I have 5 or 6 here. Once I complete the design, so I put them into one side because it's one road. If I am going to do another road, then here in this drawing itself, if I am going to do another road, what I am going to do is I am going to have another site. So you can create a site here. Okay, say site 1. Then alignment style, of course, here you will have to use, because you don't use this template, right? This is for educational purposes I have prepared. For your case, you will have to use the RDA one. Okay, there will be something called RDA whatever, there will be there. So you have to select that one. And in the RDA template, you don't have this UM. Okay, then press OK. And then you are getting a tool set. So using these tools, you will have to design the alignment. Now we will try to design. Now first thing, in Civil 3D, there is some basic theory. You have to start either from a fixed line or a fixed curve. Why? You are going to peg it somewhere. Okay, you have to peg the alignment, because after that you are going to change it here and there. But in some place you have to peg it. Otherwise you are going to design it in Colombo and it will end up in Delhi. Okay, so don't do that way. You peg it first. So here, depending on the geometry, you can see it's a line. It's not a curve. Although this is some, because who drew this line? This one was drawn by the surveyor. Okay, he is not an engineer. That is why the line is somewhere like this. Okay, because you never get a bridge like this. Bridge is straight usually. So it should be a straight line. So we'll try to fix a straight line here. Now before the computers came, this curve fitting, yeah, they called it curve fitting. You know why? Because we drew by hand and there are a set of curves, curve box. You take one curve and then try to fit. No, it's not going to work. You keep it aside, then take another curve and try to fit. So that is why it is called curve fitting or curve fixing. Okay, so we'll try. Okay, the first thing we can do is fixed line, 2 points. So you start from now, when you start here, you can have offset on using F3, right? Offset on, and after that don't put offset, because then what will happen is it will go wherever it wants, not where we want. Then again put F3 or snap off. Here you try to fix it as much as possible to the existing center line. So you should have a good eyesight, right? That is why I removed my specs, okay, to get good eyesight, right? Okay, now you can see once you drew the alignment, here you are having, now these green color ones are called major stations and these blue color ones are called minor stations. Sometimes we don't give minor stations, only the major stations, but of course I'll tell you how to switch off this later, but we'll go with both minor and major. Okay, then you have to refer your table. For 50 kmph, what will be the minimum curve radius? What is the minimum curve radius for 50 kmph? Now super elevation, your book gives super elevation up to 10%, but please remember in urban areas we go only up to 4%, okay, not beyond. So for 4%, if I remember correct, your minimum curve radius is 90 meter. Check it. 50 kmph. Is it 90? You don't know where it is. Give me this one. Very good. Huh? Under horizontal alignment. Page 44. Here, for 4% it is 95, not 90. It's for 5% only, it is 90. Okay. So, try 95 because, so you may be wondering why I say 95, because that comes with your experience. Okay, now looking at that, I can see that this is not going to cater for 90, but anyway, we'll try to go for 90 first, 95, right? So, select from here, not fixed curve. Here, if I expand it, I am having plotting curve from entity radius true point. That is one option. There are other options to do, but we'll do this one first. And it says select entity to attach to. I'm going to select this and specify radius. So I'll give 95. Enter. Is curve solution angle greater than 180 or less than 180? Now I don't understand why they are asking this one, because what they are telling is when there is an when two lines intersect, one one angle is always lesser than 180, other one is always greater than 180. They are asking to take this side or that side. Of course, in alignments we take this lesser side. Okay, so you have to do lesser than 180 and see that they are trying to draw it. If you are going to draw it this way, but you have to match it with the existing road, right? So this is how it is coming. Is this possible? It's not possible because it is coming almost to the mid of the bridge. So here you will have to reduce your speed and go for a lesser design. Okay, so press escape, it's gone. Now maybe so what is the other one? If the 50 is not available, not possible, it's 40. For 40, for 4%, how much? 55. So we'll try 55. Here then again you don't want to go here and select. Here once you select this one, it is already there. Okay, if I select fixed curve here, it comes there. Now because if I selected the plotting curve, it comes there. Now again you can just press here, not expanding, right? Select entity to attach to and then specify radius. So we'll go for 55. Enter. It should be lesser than 180, therefore enter. Specify endpoint. So it should come like this. Is this possible? No. Why? No, your bridge is here, right? It should be here. No, bridge is here. Now if I put it this way, the problem is not with the bridge. Huh? Yeah, land acquisition, that you are going to acquire this big house. Okay, that is not really good. But that depends, because you see, highway design is an art, right? So there is no right or wrong things. So you have to take decision depending on the site conditions. Now just think that this house, say some old house, and it is going to collapse or something, then of course you can acquire it. But if this is a 5-story building, then you cannot acquire it. So you have to take the decision depending on the site condition. Okay, if 50 is not possible, the 40 is not possible, then we'll have to go for 30, right? So what is 30? 30. It's 30. So maybe 30 will be ideal. You see, I'm selecting this one. 30 lesser than 180. I think you can go for 35 or something, right? Here you should never do like this. Why? You are narrowing the curve. You should never narrow the curve, right? So we'll try with 35, say. 35, enter, enter. What about this? It fitted. Okay. Then you have to have a straight line. So for that you can have getting from here. Earlier we got fixed line, never go for fixed line again, right? That should be floating line. Floating line from curve 2 point. Then it says select entity to attach to. You attach to this alignment. Now when you are going to select it, select from this edge, right? If you are going to select from somewhere here, say a free or floating line cannot be attached to another line, so it goes to the other one. Therefore you select from this edge, right? Select it, specify endpoint. What is this symbol? That is, there is no feasible solution. Why? They should be tangent, right? They should be tangent. So you can try to match it as much as possible to the existing center line. Now you see, if I am going to put it this way, it's not going to match. So that means the curve is coming in between. Can you see? But that again depends upon your design strategy. Whether you are going to go for a straight curve, straight like this, or whether you are going to have a curve in between. Okay, both are possible depending on depending on your funds, depending on your design strategy. So that means the design strategy in the sense whether you are going for minimum acquisition or whether a liberal acquisition is possible. All these things that you have to consider when you, because it's a rehabilitation project. But if it was a new road project, of course you never have curves in between in very short distances like this. In that case there is no problem, you have to go this way. Okay, so for the convenience we'll go this way, otherwise it will be difficult for your first exercise. So I'll put it that way, right? Again then comes, there comes a curve. Although you see it as one curve, I'm pretty sure this should be two curves. Okay, we'll see. Right, now always we don't go for minimum curves. If it is, if there are enough space, we can go for higher curves. So we'll have a curve like this. One thing you can do is, if you are not sure which curve radius you can put there, there's a simple technique that you can use using AutoCAD. Here can you see that there's something called here start end direction. This arc, you select this arc, start point here, then say I think endpoint should be somewhere here, then try to match it. It's somewhat matching, right? This is just a guideline, okay, what I'm telling, right? Then you select it and press LI and enter list. So what is the radius? 76. Radius is 76. So we don't go for 76 something like that. It should be better if we can go for 75 or 80. 75 means what is the speed? It's 40, right? Oh, it's 40. Yeah. So anyway it is 75. So what to do? So we'll go for 75. Floating curve. Select entity to attach to. Then radius 75. lesser than 180. Now look how it comes. Now 75 is lesser, you can see. If I put it this way, it is lesser. But we'll put it this way and try to change it. Right click means enter, right? And then what you can do is you can see the properties. Here can you see pick sub entity, and you select it. Shall I do it again? Select this one. If it is not coming, if the table is not coming, you have to click this table first, right? And then select the pick entity. Now radius is 75, so you can change, give 80. 80 is not going to work. Say 77 or something. Exactly matching, but no, 77 is not exactly matching, so 78 may match. But don't go for odd values like this. We'll go for 80. Okay. So that all depends upon your design strategy. Or one thing you can do is, if it is not going to match, you can select it from here and then try to match it somewhere there like this. See? Okay. So there are various methods that you can try. And then after that it comes a compound curve. So for this one we'll say I'll try with 100. Okay, I'll try with 100. Floating curve. Here select end to attach to. I selected this one. Specify radius 100. Is curve solution angle lesser than 180. Enter. Is curve compound to compound or reverse to curve before? For the before curve, it should be compound curve, right? So I can just put C, enter, and it's not going to work. See, where is it coming? Then if I am not sure what is this curve, again I can do the previous technique, start in direction. So I'll check here, here, it's coming somewhere like this. I'll select it here, Li. It is a lesser radius, 59. So I can go for 60. Plotting curve from entity. This one. Specify radius or degree of curvature 60, and then lesser than 180. It's compound. See, now it is working, right? Then time to time you have to save the drawing. Then there's a straight. Okay, so you can select floating line, select entity to attach to, and then try to match it as much as possible to the existing center line. Here it is not perfectly matching. If you really want some perfect matching, you will have to take the here and then put an IP or something like that. Shall I do it that way also? Here you can come here, right? Then you can put that IP. IP is you know, here tangent, no curves. sometimes you will have to put an IP. Okay, it is called tangent no curves. Here specify start point, so putting F3 or snap, you have to get the correct point, and then switch off F3 or snap, and then you can put it this way. Here can you see, now there is an IP there. Okay, intersection point, no curve. What is the prerequisite for this? You have to measure this angle and check whether it is lesser than 1 degree. No, 1 degree, yes. Then there is another curve. Okay, so again plotting curve. So I'll just go for a wild chase, say 100, so then 180. 100 is not going to work, but one thing I can do is I can correct it. Select it and then give, say, VC 200. What happens? Say 250. Seems okay. And then another curve, so that may be also 250. Reverse this time. I'll just show you again because I didn't tell you how to do reverse one. Select select entity to attach to, select this one, say 250 radius, lesser than 180. This should be reverse R. Right, so it's matching. And there's another curve. It's a sequence of curves. This may be again 250. Is this a good alignment? No, it's not a good alignment. Okay, we are not going this way putting curves and curves because we have to have straights in between. But unfortunately, this is a rehabilitation project. There is very little change we can do. So degree of not the degree of curvature, radius 250, less than 180. It should be reverse R. So it's not 250, so we can correct it a bit. See, select this one, say I'll go for 200. 200 is a perfect match. Then there's a small straight section. Again you take the floating line, select this one, and then the end point. Okay, then again you have to check about this curve. Say this curve is somewhere around I think it's something like 300 meters. We'll try 300. Then it should be lesser than 180. Specify endpoint. It's not 300, maybe it's 280 or 270 rather. 250. 250 is a perfect match, yes. And then we'll have another straight. here, and again another curve. How much should be this one? 250, do you think? No, it is not 250. So you can correct it. Say 200. No, say 180. 180 is almost okay. And then again you have another state. So this is how you are going to do the alignment. So I'm not going to go to the end of this one. There's no point. So you can complete it. And one thing I can show you. Okay, save the drawing, right? So right, then we created the surface at the beginning. Did we use it here? No, we didn't use it. So why did we create it? Now I'll show you. Now just think that you are going to take a decision whether you are going this way or that way. Now only here, right? Because otherwise you can't go this way. Why? Then you are going to narrow down the curve. You never narrow down the curve, but just think you want to check whether you can go to this side. Okay, how you are going to decide on that at the office itself before going to the site? So one thing you can do is you can just draw a line. How do you draw a line? L enter, right? L enter, you draw a line perpendicular to this one, the alignment. Perpendicular means roughly perpendicular. Okay, need not to be exactly perpendicular. Then you can create a profile here and check how. You select this one, right click, quick profile. Okay, quick profile. Here EG profile style existing, profile view style 1000 UM. Now in your case you will have to put RDL. Okay, and then I am going to draw it. Now this is the cross section. This is the cross section of this section. Here can you see here somewhere around say 37.5 is coming to 35.5, so that means it's somewhere around 2 meter gap, right? So you have to decide whether you are allowing this 2 meter or not. Okay, now if I am going to say I am going to change this, we say I select this, say now our toolbar is gone, right? If it is gone, how you can take is you can select the alignment, right click, edit alignment geometry, and then select pick sub entity, select this one, the curve, and say I'm going to give it 50 and right click. Now it will show how, depending on this one, how your cross section is going to change. So you want some practice. With the practice you can decide whether it is okay to improve this or not. Okay, right. Then other thing is usually we don't give chain edges in each 10 meter intervals. Sorry, 20 meter. Yeah, in each 10 meter intervals we don't give this detail. So what you can do is, so we want to delete, not the delete, we want to switch off these things. So how you can do that is you have to select the alignment, right click, edit alignment labels, edit alignment labels. There, this is minor station. You have to select this style minor here, and then you can go to pick label style. It is minor. You can go to edit, right? There you have to go to layout. Here you can see there are three: tick, line and text. Text will remove. Select text, give visibility false, and select line 1, give possibility false. The tick of course will keep. Okay, then okay, apply, okay. Now you can see only your visualizing the major chain edges, but for the minor chain edges you are just having the tick. That you can do it yourself. Okay, now you just think that how easy with the software. Otherwise, now if somebody drew by hand say 1 kilometer, and he has put for each 10 meter interval these chain edges, and your boss says no, you have to remove each, I mean all these minor things. What you have to do is you have to take an eraser and then erase everything. But with this software, with few clicks you can do it yourself. Okay, now I think you will have to practice this one. Okay, because I'm not going to go for because you have 1 year, right? So what's the point of just speed driving there? uh, so practice this one. So next week we'll try to do the, we have to go for the profile, but before profile we have to go for super elevation and things. Okay, so these things we'll study. mm, yeah, what is your suggestion? Are you ready to go for some more, or shall we stop here? Tell me your suggestion. Huh? Yeah. Yeah, the purpose is that of course you can check whether you can go to this side or that side. Why? Because the elevation difference is shown. Okay, with the elevation difference you can decide. Not the corridor, it is only the cross section there. Now if I draw a say here I am going to draw a quick profile. Okay, here this is how this is the cross section. Just as if you cut it here, this is how you see that cross section. Now here of course, because it is flat, you don't have to decide whether to go this way or that way. But just think it is somewhere where there is a precipice, of course, then you can consider whether you can go to LHS side or RHS side. That's the purpose of it. Now you need not to check with the quick profile. If you want only, you have to check. Otherwise, what the easiest thing is, you go to the site and then check. Okay, but just think that if your road is say somewhere in Bandarwell or something, before going to the site, the best thing is before going to the site you have to do all the corrections as far as possible here. Then you go to the site and then do the minor corrections there. Then go to a waterfall and then take a bath and then come back. Okay. Otherwise, if you are going to do all these things at the site, it's not going to work. So the 2 days are not enough for that, right? So that is why we are going to correct. No, of course, why we are going to do is now this is not meant for Sri Lanka. Now in say now just in some big country. Okay, now if you consider America, maybe one state is much larger than Sri Lanka. So you are going to do a design. So at the office you should be able to do all the corrections as much as possible here. Then only you are going to send it to the site for the site engineer to attend. And again, other thing is, now in our country, of course, we are going to site because our country is small. But if it is a big country, of course, the design is not going to site sometimes. So it is being corrected by the site engineers there, and they are not technical experts. That is why we are trying to do it here as much as possible. So the usage of quick profile is to correct the alignment. That is also roughly. Please understand this roughly. Okay. For the complete correction, you have to create the corridor and then you have to go for the cross sections, and then using the cross sections only you have to go for the absolute correction. If the survey has done its work correct, of course this adjusting the alignment here and there you can do it office itself if the survey is correct. But if the survey is not correct, because if he has made some error somewhere here and there, of course, then of course you have to go to the site. Understand?